Typically, when we are getting data, the rows are being displayed in the order in which they are entered or inserted in our database table. The order by clause gives us a way to list our data in any desired order. The column in which data is to be sorted is called the sort key. We can have multiple sort keys in our order by, and they are listed in the order of importance. The sort in descending order use the descending operator, and if you would like to put it in an ascending order, can either do so by saying ASC or just completely ignoring it because the default is ascending. In this example, we would like to get an ordered result by state in descending order and then by city in ascending order. As we can see after our where clause, we have our order by clause. And we started with our state in descending order and then by city. Again, if it is ascending, we do not need to put ASC because that is the default. Alternatively, we can also use the position of the columns in the select clause. The same result is what we are getting in the previous example. If we have used column aliases in our select statement, we can also use them in our order by clause, as we can see in this example. We can also have expressions in our order by clause, as illustrated in this example. If we have null values in our sort key, they will appear at the end of our result, as we can see in this example. To override the placement of the null values, we can use nulls first or nulls last. In this example, we can see that we have used nulls first. That is why the records with the nulls appear first in our results. Imagine in our books table, we have thousands of records of books with different categories. If we would like to know what are the categories in our books table, we can use the distinct keyword to get the distinct categories, as what we have done in this example. SQL supports aggregate processing. With aggregate processing, we are taking a collection of rows and reducing it to a single row. SQL provides useful aggregate functions that count, find the maximum and minimum values, calculate averages, and some others. To do aggregate processing, we need to group our data first, using the group by clause syntax. The following table summarizes some basic SQL aggregate functions. For example, if we would like to determine the number of customers and the number of distinct class names in our customers table, we do so using the following statement. To determine the total number of customers, we just use the count function, and then inside the count function, we use the asterisk to count all of the records in our table. To determine the number of distinct class names, we just use the count function, and then inside, we use the distinct class name. Take note, if we do not have the distinct keyword, we will just get all of the records in our customers table as well. If, for example, we would like to determine the maximum retail price of any book, we do so using the following SQL statement. We use the max function, and then we pass on the name of the column inside our max function. Now, to determine the total cost of all the books in our database, we use the sum function, and then we pass on inside the name of our column. Now let's talk about the having clause. The having clause operates very much like the where clause in the select statement. However, the having clause is applied to the output of a group by operation, as we will see in the next example. For example, if we need to determine the total retail price of all the books from each of the publishers in the database, we do so using the following. First, take note that the name of the publisher can be found in the publisher table, while the retail price of each of the books published by certain publishers can be found in the books table. That is why we need to join the two tables first. Next, we are grouping all of the data by publisher name. Once we have grouped all the data by the publisher's name using the group by clause, we can now use the having clause to only include those aggregated data for which the sum of the retail price is greater than 5. And as we can see in the result, we now have the name of each of the publisher and the sum of each of the books published by each of the publishers. Let us now talk about subqueries. A subquery is just a query or a select statement inside another select statement. A subquery is normally expressed inside the parentheses. The first query in the SQL statement is known as the outer query, while the query inside the SQL statement is known as the inner query, or the subquery. The inner query is executed first, and then the output of the inner query is used as the input for the outer query. The entire SQL statement is sometimes referred to as a nested query. A subquery can return one or more values. It can return either a single value, a list of values, or a visual table. The following are the types of subqueries. We have the where subqueries, which is the most common type of subquery, the in subqueries, the having subqueries, the multi-row subquery operators all and any, the from subqueries, and the correlated subquery. For example, if we would like to determine the name of the customers with orders that are not yet delivered, we can do so using a subquery. Let us take a look first at our inner query. In the inner query, we're selecting the listing customer number from our orders table for which the ship date is null, meaning the order is not yet delivered. And then in our outer query, we are selecting the first name and the last name from our customers table for the customer number appears in the results of our inner query. And our output, these are the names of the people with orders that are not yet delivered. In another example, if you would like to determine the title of books with retail price less than the average of all retail prices, we can do so using the following. First, let's take a look at our inner query. In our inner query, we're first selecting or computing for the average retail price from our books table. And then that single value, which is the average retail price, is what we're going to use in our outer query. In our outer query, we're selecting the title from books for which the retail price is less than our average price that we have gotten from our inner query. The results can be found on the right side of our slide.
In summary, we are able to discuss the following. We have learned how to update data in our tables. We have learned all about database transactions. We have also learned how to make use of comparison and logical operators, how to manage aggregate processing, and how to implement subqueries in our SQL queries.